Hello everyone. In this video, we are going to discuss about the introduction to finite automata. Let's see what finite automata means. Now, in our previous video, we saw what an automata is. To recollect what an automata is an abstract machine with which you can solve computational problems. Right. So now what is finite automata? Finite automata is designed to recognize patterns. So that's the main idea behind designing finite automata. It is used for recognizing patterns with which we can design machines. And what does the finite automata do? The finite automata will take the string of symbol as input. That is, it will take a string as input and it will move from one state to another according to the given input. And when the desired symbol is found, then you would have a transition. So this is how a finite automata will start working. And when it is transiting from one state to another, the automata will either move to the next state or it may say in the same state. So that depends upon the input that is being applied to the particular state. And finite automata will have two states. One is called as the accept state or the reject state. And when the input string is processed successfully, right, when you're able to process your input successfully, we will say that the automata has reached its final state, which means it has been accepted. Right? So this is what is meant by a finite automata. Let's look at the formal definition of a finite automata. A finite automata is a collection of 5 tuples. It is a collection of 5 tuples, Q, sigma, delta, Q naught, F. Now we will see what each means. Q is nothing but it is a finite set of states. Sigma is nothing but the alphabet or the finite set of input symbols. Delta is nothing but the transition function. Q naught is the initial state. F is the final state or accept state. So a finite automaton can always be defined as a collection of 5 tuples, namely Q, which is a finite set of states, sigma, which is a finite set of input symbols, Q naught, initial state, F, final state, and delta, which is the transition function. So coming to the different types of finite automata that are available, we have two types of finite automata, namely deterministic finite automata and non-deterministic finite automata, very commonly called as DFA and NFA. These are the two different types of finite automata that are available. Now let's look into what is DFA and what is NFA. Now coming to what is a DFA. DFA, as we already saw, it is nothing but it refers to deterministic finite automata. What is the meaning of the word deterministic? Deterministic means uniqueness of the computation. Uniqueness of the computation. That is, when you have a DFA, the machine will only go to one state for a particular input. That is the main uniqueness of this computation. When I'm in a particular state, if say for example, I'm in state Q naught, and upon some input symbol, you will either be going to another state or you might say in the same state. So for a particular input symbol, you will not be able to transit to two different states. You will be able to only go to one state. And that is the uniqueness of the computation. And DFA will never accept null moves. Null moves means it will not accept any empty string. Empty string is represented as epsilon. DFAs will not accept epsilon as input. Coming to what NFA is. And NFA refers to what it is called as the non-deterministic finite automata. And with a help of NFA, you can transmit to any number of states for a particular input. So that is basically the main difference between DFA and NFA. Say for example, if I'm in state Q naught and upon input symbol A, I'm going to Q1 for DFA, I may go to Q naught as well as Q1 in NFA. So that is the difference between DFA and NFA. And another main difference between DFA and NFA is NFA accepts null move. NFA accepts epsilon as input. So these are some of the important points about DFA and NFA. The first one, every DFA is NFA, but NFA is not DFA. You can have multiple final states in both NFA and DFA. DFA is used in lexical analysis for compiler design. NFA is only used for theoretical study. So these are some of the important points that you need to know about DFA and NFA. So with this, we will stop our current video.